Okay, last time we had our basic power rule for derivatives, and we had some techniques that we could simplify so that we only had to use the power rule. Today what we're going to do is find out about what happens when we multiply or divide two different factors. If I have an example, you don't have this, but just observe. If I have f of x equals 3x squared plus 4 times the quantity 2x minus 5, we know the right way, based upon last time, is to multiply it out. So we will have 6x to the third minus 15x squared plus 8x minus 20. From there, it's real easy. We just do our power rule to find the derivative, and we know the correct answer is 18x squared minus 30x plus 8. However, some people will forget this and they will try some crazy things. They might think, oh, let's take the derivative of the first and we will get 6x, and then the derivative of the second, which is 2, and that is 12x, which does not equal the correct answer. So therefore, you don't just take the derivative of each and multiply. There's got to be something else going on. So what is it? It is known as the product rule. And the product rule, as they have stated, is the derivative of the first times the second plus the derivative of the second times the first. Now that's kind of hard to remember. So what students like last year, I have a bow tie method, and we write our factors. So if I have f times g, I write the derivatives, f prime, g prime, and it's truly just a way to organize our thoughts. So then once I have all the pieces, the bow tie, I always start from the bottom left, go to the top right, around, and down. So f prime times g plus f times g prime. So that's the method I'm going to use. Again, it's just an organization tool. All right, so for part A, and you can pause at any time, I'm going to write my factors, 4x squared, e to the x, find their derivatives. Remember, derivative of e to the x is e to the x. And then I'm going to do the bow tie. It is plus. Start from the bottom left. So f prime is 8x e to the x plus 4x squared e to the x. That may be an answer, or for multiple choice, they will want you to factor out the common factors. In this case, 4x e to the x. And what's left should be 2 plus x. All right, for part B, I'm going to do the same. Write our factors. We have x squared plus 1 e to the x plus x. Find your derivatives. Derivative e to the x, e to the x. Derivative of x is just 1. And then the bow tie. Remember, it's plus. All right, so for the derivative, I'm going to start from the bottom left. Don't forget the parentheses. 2x e to the x plus x plus x squared plus 1 times e to the x plus 1. I'm going to stop there because I don't think there's much going to happen with that. So moving on. For the quotient rule, hopefully you believe me when I say there's more going on. Here's the shortcut. The only way we can do the quotient rule, again, look at the rule. It's very, looks very busy. From high school, what I remember is I always started with the denominator. Denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all over the denominator squared. Another way people remember it is we start with low, d high. D is for derivative, so low times the derivative of the high, numerator, minus high d low, all over low squared. All right, now, since learning the bow tie, I use it again in the same fashion with one little twist. Again, write our numerator goes first, denominator, take the derivatives. I'm going to do the bow tie just as before, but this time it's a minus. Now I will tell you, last year, my biggest flaw was that I forgot to have the denominator squared. So this year, I vowed to always put my denominator first. All right, start from the bottom left, just as before. Negative 2w times the family 1 plus w squared minus, I'm out of room, 2w, 1 minus w squared. All right, let's distribute. Something hopefully will happen. Do not FOIL the denominator. All right, looks like negative 2wq plus 2wq is 0. And we have negative 4w over 1 plus w squared squared. All right, part D. In this case, I'm going to write the radical with a rational exponent. And here's where it helps me to do my work in that corner. And remember, that'll be x to the negative 1/2, or that is 2 over square root of x. All right, so this is my answer down here. So there's my bow tie. It is a minus. So for k prime of x, don't forget denominator squared. All right, bottom left. So we have 2 over the square root of x times the family x squared minus 4 minus, oops, 4 square root of x times 2x. All right, now I do have a complex fraction. I don't just want to drop the square root of x to the denominator. I do need to get a common denominator up here. So cleaning it up, I have 2x squared minus 8 minus 8x times x all over square root of x. Don't lose the denominator. All right, let's clean it up. It looks like we have 2x squared minus 8x squared minus 8. Now the square root can go to the denominator. Final answer looks like negative 6x squared minus 8 square root x squared minus 4 quantity squared. All right, in this example, they're going to give us a function and they're defining it as y equals f times g. So I'm going to organize f, g, and I'm going to do the bow tie. Remember, product is plus. Okay, in the end, they want us to find y prime of 2. They have a table of values that we just have to use. Other ways that we can have this, they might give us a graph of a line. Remember, derivative is just slope of the tangent line. All right, so first thing we're going to do is write down what the derivative of our product looks like. And that will be f prime times g plus f g prime. Now I'm ready to find y prime of 2. All right, now that I have 2 substituted in, we can find the values from our table. F prime of 2 just happens to be 2. G prime of 2 is listed as 3, plus f of 2 is negative 1, and g prime of 2 is negative 4. So what we have is 6 plus 4, or 10. Okay, for example 3, let's read the directions. It says find the equation, so that means I need point slope, of the tangent line, which means I need the derivative, of the graph, and they give me an ordered pair. Now, I'm not really sure what the best way of doing this, so let's just get started. I notice that it is a quotient, so I'm going to regroup. Okay, and let's find the derivative. So that is, all right, x to the negative second, 1 over x squared. The derivative here is 1. All right, let's do our bow tie. It is a quotient, so I want minus. So f prime of x is equal to, start from the bottom left, 1 over x squared times x plus 5 minus 1 times 3 minus 1 over x. All over, don't forget your denominator, x plus 5 quantity squared. Now I could get the common denominator, but that looks scary, so what I'm going to do is cheat and find the derivative they gave me when x is negative 1. So we're just going to plug in our negative 1 right now. So I have 3 minus 1 over negative 1, all over negative 1 plus 5 squared. All right, let's clean it up. Looks like it's a 1 times a 4, 2 negative positive, minus 4, all over, I believe that is 4 squared. Final answer, 0 over 16, or 0. That is a special line. It's going to be our horizontal tangent line. Keep that in mind for later. So our slope is 0. Our point is 1. So now we can write our equation, which is t of x minus 1 equals 0 times x plus 1, or t of x equals 1. And there's your final answer. All right, with your group members, take a look at example 4 and just discuss how you would solve each one. Is it an easy one where you would use just the constant multiple rule, or would you have to do something more complicated using the quotient rule? And just discuss why you chose the method you would. All right, example 5. This is going to be more important when we get to implicit differentiation. We do need to recognize that as a product. So I'm going to break up the two factors as 3x squared. Notice the 3 goes with the x squared, keep it together, and the trig goes by itself. So we can take the derivative of each piece, and the derivative of sine is cosine. You do need to memorize that. And now I'm ready for h prime. Let's do our bow tie. and it is a product, so it's plus, and it should be 6x sine plus 3x squared cosine of x. Okay, so the derivative, they might ask us to take other derivatives, the first, the second, or more. These are known as the higher order derivatives. Here's where our applications come into play. Some notations that they will have us use. Oops, wrong way. Your first derivative is like y prime. We could have double prime and to the third. After the 3 tick marks, then they tend to use numbers. Same thing with function notation. dy dx, the most common would be the first and the second. All right, so let's take an example. Just starting with normal. For example 6, part A, they want us to find the third derivative. So I'm going to use f prime, just normal, power rule, so 20x to the fourth minus 9x squared. Derivative of the constant is 0. And let's now take the second derivative. What's that? 80x to the third minus 18x. And the third derivative, 240x squared minus 18. All right, for part B, this one is ugly. Your choice, you can do it as a quotient. Some will bump up e to the x times x to the negative 1 if they prefer to do a quotient, or I'm sorry, a product. I'm going to go with as is. So first of all, let's organize. We have e to the x, just x. Take my derivative of each, and let's take our first derivative. And remember our denominator squared. Let's do the bow tie, and it's quotient, so I want minus. So this should be x e to the x minus e to the x. Now for a second derivative, I see another quotient. And it might be better if we change it to a product, but let's go with it. We have x e to the x minus e to the x, denominator x squared. But I have a problem. This is another product. So off to the side, we have x e to the x so x e to the x, and let's do the bow tie here. We're going to bring it up, which is e to the x plus x e to the x minus the derivative of e to the x is e to the x. It's ugly, but it looks like we have like terms which will drop out. All right, so let's do bow tie. This is quotient, so it's a minus. Our second derivative, don't forget denominator squared, so that will be x to the fourth. And it looks like we have x squared times x e to the x minus the family x e to the x minus e to the x times 2x. I'm going to clean up what I can. X to the third, e to the x, minus, I'm distributing the 2x, looks like 2x squared, e to the x, plus 2x, e to the x. All over x to the fourth. You might need to pause to digest that. All right, let's look for common factors in the numerator. We all have, looks like we all have an x and an e to the x. Let's factor that out, leaving me with x squared minus 2x plus 2 all over x to the fourth And look at that. We can reduce by a factor of x. Remember, calculus is just algebra on steroids. And this would be the answer. All right, last problem is an application problem. We have a ball that's dropped or propelled vertically upward from the ground. So remember, ground means our position is 0 with an initial velocity of 29.4 meters per second. The height is given by the function s of t, where t is the number of seconds, and s is our position from ground. It's our height in meters. All right, this is a typical application problem. So you might need a calculator because especially if the numbers are decimals. So part A wants to know what is the velocity of the ball at time t. That's just our generic velocity, so we're going to take the derivative. Old school, so that's negative 9.8 t plus 29.4. But part B wants the velocity at t equals 1 second, so we want v of 1. This is known as the instantaneous velocity. So v of 1, let's plug it in. Type that into the calculator. By magic, that is 19.6. And that should be in our velocity. It is meters per second. All right, part C, when will the ball reach the maximum? You know from Algebra 2, we're looking for the vertex. And anytime we launch something, it makes a parabola. Well, here on the as the ball is increasing, our velocity is positive. Our slope of our tangent lines are positive. When the ball is falling, a slope of our tangent line is negative. So therefore, right at the top, our velocity is 0. So we want to find when v of t equal to 0. So let's take negative 9.8 t plus 29.4 equals 0. And I believe t turns out to be 3 seconds. But now part D, if we know the ball's been reaches the max at 3 seconds, we want to know what is the maximum height. Oh, height is s of t. So we want to plug in 3. I only knew what the formula was. And it is negative 4.9 times 3 squared plus 29.4 times 3. And that should be 44.1. And that is in meters. Hey, part E for acceleration. Remember, acceleration is the second derivative of position, or it is our derivative of velocity, and it's denoted as a of t. All right, so take the derivative of velocity, and you will get negative 9.8. And that is meters per second, or meters per second squared. All right, for part F, they want to know how long is the ball in the air. Well, the ball is no longer in the air when it's sitting on the ground or when the position is equal to 0. So what we will do is the position, negative 4.9 t squared plus 29.4 t equal to 0. Let's see, it looks like I can factor out a t. Now, do not always assume. But when you work out t equals 0, it starts off from the ground. And the other quantity, when you solve for t, you get t is equal to 6 seconds. Now, it's a coincidence because it starts off at the ground. You do have symmetry. Do not always assume that it's double where the vertex is. So the ball's in the air for 6 seconds. Now we want to know what is the velocity when it hits the ground. So velocity is v of t. So we want the velocity is 6 at 6 seconds, and that is negative 9.8 t plus 29.4. Plug in our 6. And that answer should be negative 29.4 meters per second. All right, velocity. The negative lets me know that the ball is dropping. For part H, total distance. Total distance, well, if the maximum height was 44.1, up and it went down 44.1, then our total, we're going to add those together. We are going to see that written differently in January, February. Sorry, that should be 88.2 meters. Distance, remember from Algebra 1, is always positive. The negative shows us direction. And though that is a quick summary of the notes for today, I ask that you work with your groups to do the homework. The answers are on the back of the worksheet. Please try the AP questions as well. There will be a concept check next time.